Here we are at Quincy Mine in Hancock, Michigan, looking at a historic copper mine. Around me, you'll see lots of the workings from this mine, including a shaft house built in 1908. There's also other buildings around here, including boiler houses and hoist houses and all the different structures that would support mining. Quincy Mine operated from 1846 to 1945, extracting over 1 billion pounds of native copper and over 4.5 million pounds of native silver. Now, that's just this mine alone. This entire mining district extracted over 14 billion pounds of pure native copper. Now, most of that was from a mining operation north of here called Calumet and Hecla. Now, why is all of this native copper here? Native meaning pure. So this native copper and native silver, there's a whole lot of it. In fact, this is the world's largest native copper deposit. Like I said, why is it here? That's because of the mid-continent rift system. About 1.1 billion years ago, a rift opened up here, and that's where a continent splits apart. When that happens, you get lots and lots of lava erupting, basaltic lava, and that you had layer upon layer of this basaltic lava forming until it was many kilometers thick. And this lava is heavy, and so the Rift Valley started to subside, and the rocks started to heat up and get warm, and you get these warm waters flowing through all of this basalt. Now, basalt carries just a little bit, trace amounts of copper and silver. And as these warm waters traveled through that basalt, it would pick up some of that copper and some of that silver and carry it through the rocks. And this would move through what we call the permeability, the open spaces of the rock, and it would eventually deposit or concentrate that copper and silver in the porosity of the rocks, the open spaces. Now, lava does not have a whole lot of open space in it. It doesn't. But when you have lava flows forming, the top of lava flows can sometimes become what's called brecciated. That means broken apart. When it's broken apart, in between those broken pieces, there's space. The other thing that happens in lava flows is lava contains gases that bubble out, and the tops of lava flows can get what are called vesicles in them. They're these little bubbles of gas that get trapped and create open space. So when we had all of these warm fluids carrying the copper and silver, well, it would find its way through the flow tops where there was breccia and these vesicles, these open spaces, and it would deposit the copper in those locations. And that's what the miners here at Quincy were looking for. We're now underground at Quincy Mine, and over the 99 years of operation, this mine had 92 levels, which reached over 9,200 feet deep. We're on the 7th level here, and you'll see that 1,300 over there. That means we're 1,300 feet in from the entrance to the mine. Now, what we're looking at here is what the miners would have been looking for where the rich ore was. I mentioned that the tops of lava flows get brecciated or get these gas bubbles developed in them, and that's where the warm water that was carrying all the minerals would flow through and leave those minerals behind. And if you look here, you will see these two areas where there's a lot of white and green. There's one here, there's one over there, and these are the tops of individual lava flows. So we're looking at actually two different lava flows that were filling up that mid-continent rift system. So a flow top here, a flow top there. Now, they're not flat, they're not horizontal, and that's because, remember I said the lava flows were subsiding, and then we also had some fault activity, and that tilted those lava flows on end. But in any case, it's these flow tops that the miners would look for because that's where the rich ore is. And if we look in here, you'll see these little round or oval areas. Those were the gas bubbles in the top of the lava flow. We call them vesicles when they're not filled with minerals, but we call them amygdals when they get filled with minerals. So we would call this an amygdaloidal basalt. And this is exactly what they would have looked for, because it's in those little open spaces where the water left behind our copper and our silver, and that's what made this mine rich. Now, to know more about this mine, there are actually tours operated, and you too can come down here on the 7th level and experience what it would have been like to be a miner in the 1800s here in Michigan. So just visit Quincy Mine in Hancock, Michigan for an amazing experience.